G'day Bifrosters, welcome back. So what we're doing today, or what we're doing this episode anyway, is we're going to put in our new Worleys. If you've seen the Worley fix episode, you'll see that I've rebuilt the Worley noise to be a lot more efficient, and now the three distance metrics work. We're putting in two more noises here, so curl noise and fractal noise. Curl noise is good, it's nice. We'll work on that in a second. First thing we'll do is we're going to hook up these two new Worleys, and then we're going to just add some stuff to our interface to cope with them. Right now we're pretty much where we left off in the last noise episode. We've got a bunch of noises which I can switch between here. There we go. We've got a bunch of noises we can switch between. It's automatically scaling it by the amplitude up here. And it's also generating a color map from black to white based on the noise's height. We're going to keep that. What we're also going to do, which will make life so much easier for everybody, is we're going to build an enum that switches between all of our noises. But to do that, we need to get all of our noises fairly final. So let's work on the Worley first. I'm not going to need these two anymore, so let's get rid of those. The reason I've left this interface on is because this is a handy node to have outside of a big noise as well. So the first thing we're going to need is the input geometry. There that is. That's great. We're going to need the Worley frequency. And so there's our first mismatch. The new Worleys are built with long integer frequencies, where this is a float, so that's okay. We can just do it too long, like the T, except I think that's oolong, but close enough. Get that in there as well. Now what the next one is the scatter type, and that's the three. Told you volume didn't exist anymore. That's the three ways we're scattering points for the seed points, where it's the bounds cube, bounds sphere, or on the object itself. That's going to need to be a new one. We'll come back to that. Padding is also going to need to be a new one as well, where we're actually able to lift it out or push it into the object now based on the padding setting. Seed we've already got. We can pop that into the seed there. Everything has a master seed in this setup. And just let it compile quickly. Then the distance metric, which I believe we don't have, so let's add that. Now a good thing that I practice doing when I'm building interfaces, because I'm going to come out here and sort this out in a minute later, but this is the metric, sure, but it's the Worley metric. So now you've got this turning up, Worley metric, and then when we come back out here, we can work on this later, is what I'm saying, but we'll organize our interfaces and stuff. And then you've got your F setting. So F is which index of the Worley you're picking up. It's mostly set to 0, and it's up to us if we want to keep this separate or put it together. So I'm going to keep it out into the interface here, just like that, and we will give this Worley F. Okay, so we're going to need to put out our scattering type, and we need to put out our padding. Now these two are designed, they work with a lot of the same inputs. So setting up one really just is most of the way to setting up two. And in the interest of keeping things together, Worley frequency too long, just so we know what's what. So that's got this one hooked up. We should actually be able to have a look at it by plugging it into here and giving it a minute to compile. There's something not quite right about that just yet, so we're going to need to open up these options and take a look. So the nice thing about these two new Worleys is that we can visualize the points, and that's where our problem is right now. This one is set to a bound sphere, so it's taking the longest edge of this plane that we're plugging into it and making a sphere of that radius. So we can fix this by changing this to on object, and this should scatter our points on the plane itself. There we go, we're back to what we had. That's great. And this is a nice time to show off our padding if we wanted to pad this. So this just multiplies the padding by a number and adds it to the normal of the object. For a plane, not great. Not really going to help much, but if I, for example, switch this to a bounds cube and then added some padding, so say just 2, you can see that that's now changed it and scattered it throughout a bounds cube that has a bit of padding. So this allows us to get a bit of variation even on a flat plane by using the cube to scatter our points, which is great. Now I need to delete that So I need to delete that because there is no volume anymore and the group will disappear. And we've got some more options in here. We've got, if we're scattering on object, do we want to scatter it randomly with blue noise or with blue noise maximal? That's great. That's using the internal Bifrost scatter to do that. This is the sphere options. We can have some linear interpolations of how the points are scattered throughout the sphere. Let's switch that to off. And then when we've got a Euclidean output, which is what we've got right now, we have the ability to change our curve. So if you watch what happens when I change it, you can see that the way the curves work have changed, and I can maybe give us a much more visible demonstration by doing something like this, and you can see things. I mean, this is all scaled out to be the same amount of height based on amplitude and everything, but you get the idea that you can change essentially the way the curves are set up in the Euclidean to get a lot of control over the final shape, which is awesome. So we'll take that back to a preset, and I'm going to just pull this down because I happen to know that works quite well. We can put these out if we want to. Yeah, let's put these out, and we'll just call this, just so we can keep our things straight here, Worley on object mode, and maybe there should be a space in there. Worley sphere lab. Cool. And we can just reuse these attributes for the second one. So that's got that working. That's all nice. We've got all of our options, and they're all out to the they're out to the top level of the node, which is great. We'll just double check that our frequency works. I'll halve that frequency. Great. So we now have a lot more control over the Worley. So now we'll just do the same for the Worley F2. So we'll delete this guy. We'll close this guy up. And so we'll put the Worley F2 in there. And it's just the same things. Now we've got a couple of new ones. So I'm going to put these out in order, and there's a reason for that. So Worley F1, then the math operation, then F2. Cool. And finally, we'll hook up our on object mode and our on object loop. And the one thing I forgot to do for the first Worley is we're going to push this shape out as well, so that we can use that. And we'll just quickly jump back into here, grab that, and hook it up as well. So it's getting a little bit like a wiring cabinet over here, but that's all right. We'll be able to deal with that. So we'll just do a really quick check now. We've got, yeah, let's output that. This will take a little bit longer. It's got a few more calculations to do, but we should get a nice shape change once it clicks over. There we go. And again, very, very flat. Let's add some padding to that and see if that makes a difference. Good looking F2 minus F1, and we do. And last thing to check is, let's try a Chebyshev version of that. Perfect, that's working beautifully. Okay, so that's our two new Worleys hooked up. Let's double check our curl noise. Curl noise comes out as a vector, so we need to just throw that through a length to get a float version of that, because we're working with floats when we're working with noise. And change that over and see what our curl noise looks like. That's looking pretty good for curl noise, and of course we can control frequencies and things from Maya. So if I just copy that tab, close that up, extra attributes, pop that over here, deselect that, element size 2, we'll change that to an element size of 1, and that's working. 4, it's great, 2 is good, and frequency, let's go to 3, 3, and 3. Nice and fast, nice and responsive, lovely. 0.5, 0.5, 0.5, do a phase test, yep. Do an amplitude test, yep. A nice seed test, not going to do anything just yet. And that's because we have not hooked up the seed. So let's do that now. Seed, 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 there we go. Watch it change, lovely. And time, we should hook up time as well, because kill noise lets us do things by time, so why not use it? There we go, time output. So if I just, yep, you can evolve the kill noise over time. Awesome. Great, that one's working. Let's hook up the fractal noise, and fractal noise is kind of important because we're going to be using fractal noise to make detail very, very shortly. So right now our fractal noise really doesn't have anything hooked up, and close that down for now. Fractal noise is interesting. I'll change that to 0.5. There we are, we're starting to get some noise now. Fractal noise is called fractal noise because it's a fractal brain-in motion noise, which means it's using several layers of noise, each with a smaller amplitude and a higher frequency as you go down the layers, or the octaves of noise. So you can see that by, if we look at this, this has got one frequency. If I set this to 0, you get nothing, no frequencies. Just one frequency, that gives you this frequency, which happens to be 0.5, at this amplitude, which is 1. I'll change that to 2. That's not actually going to do terribly much right now because we are changing the range of everything coming out to make sure it's in the -1 to 1 range for our output. Now in the final we can throw that on an if statement and have a normalized or non-normalized noise, and that's probably a really good thing to really quickly set up now. So if I drop down an if statement like this, and it's really, really simple. We'll just, if the statement is on, we want it normalized. If the statement is off, we don't. And then those just have to go out to, no, not, this is the color. So this always needs to be 0 to 1. We'll just leave that alone. We just need to replace this one up here. Let's see what changes. Not terribly much. You can just see it move slightly as we change it. But now, if I was to go, if I leave that off and go over here and change the magnitude to say 4, you can see that this is the magnitude of the noise here. So essentially all this is doing is a normalized magnitude. And this will also be multiplied by whatever we set in the amplitude as well, so we can get it even bigger. So I quite like this idea. This is an off-the-cuff thing. We're going to leave it because this way we can choose to normalize what comes out or not, depending on what we want. So the more options we have, the better. So we'll take this, let's just, so at the moment we have one frequency, which is a frequency of 0.5 at magnitude of 1. That's that's happening. Now if I change that to 2, see, it gets a little more complicated, and we've got two frequencies, and the first one is magnitude 1 at 0.5. The second one is frequency of 1 at magnitude 0.5. And that just the same way when you add a third one, it's a higher frequency at a lower amplitude every time. And usually that's done in, well, in this case it's done by powers of 2. But if we change the ratio, so if we say 0.1, then we've still got 4 frequencies. But as I bring this up, 0.2, you can just see the frequencies are coming in, 0.3, a bit more. And we can go, oh, we can blow over it as well. So 0.8, and we're going to get quite a lot of frequency, but it stays the same patterns. So it doesn't change, it's just how much the frequency is applying to. It's kind of like how rough it is, kind of. We can do the same over here. So that makes the frequency ratio, that makes it very, very smooth. Go the other way, makes it very, very rough. Okay, so we can take advantage of these two settings as well, and I believe that these are usually 0 to 1. So if we wanted to say have quite a high frequency to start with, so quite a lot of bumps going on over our full frequencies, but then we drop this down a bit, we could then take our quite noisy high frequency stuff that we quite enjoy, and we could just drop down. So you get, drop down the effect of it. So you get quite a lot of control with the fractal noise, and that's what makes it perfect for making details. So I'm going to need to output this to our options as well. And I'm going to need to put out everything pretty much down to time. And we'll switch it back on. Give it a minute to compile, and now it's compiled and we've got controls outside of the fractal noise. That's great. Frequency. Now this is where we need to start making some name changes. I'll turn that off again. It's a bit faster. And again, we will go. So we will come back and tidy up all this. Don't be getting anything in a twist, because this is we're in construction mode, and we'll come back and clean the worksite when we're done. That pretty much completes the noises that we're going to do. Yes, I know about sparse convolution noise and how I haven't done it. I'm still looking at that. We'll get onto that. I'm starting to think that if I just do a blend on a Worley 2 and a fractal, I might get away with this. But that being said, we also don't have alligator, but we can make one. Okay. At this point, we're ready to start adding details, and we're ready to start getting everything in order for our interface. And so what I'm going to do is I'm going to go away and I'm going to make us an enum that covers 1, 2, 3, 4, 5, 6, 7, 8 different noises. In fact, it's going to be 9, because I'm just going to put in a pass node down here, and this is going to be our sparse convolution noise placeholder, like so. And all I'm going to do for that is I'm going to take our multiplied input, so this here, and no, it's gone. I'm going to run this into basically just a white noise generator. So we'll pass that. That's the array we're going to use for our array size. Nice, and I'm going to do a random value array. We can just leave this as it is, because it's not really that important. It's just a placeholder right now, but we need to have it here because I'm going to build a menu that includes sparse convolution noise, but we don't have anything to plug into it yet. So at this point, I'm going to go away and tidy this up a bit, and I will make us an enum in the normal fashion of making a text file that lists everything. I've done it several times on several different videos, so I'm sure you could find one. There's in fact one in the Worley video. These are the new Worleys, but the old Worley has the same concept, and it still has the building of an enum and how to do it. So I will come back once I've got that, and we can start tidying things up and putting in our details. Thank you. Welcome back. So as you can see, we now have a new compound called noise cases, and it has a whole bunch of things going into it and one thing coming out of it, and a menu. So yeah, I wasn't going to subject you to that while I messed around. I'd like to say that it is awfully tidy in there. It's all laid out in a grid. It's quite nice, really. I quite like it. Anyway, beside the point. So now we can change what noise we're working with just by changing this menu and waiting a little while. I have also, since you've been away, or I've been away, hooked up this condition to the menu under normalize, and the last thing we have to do, now that you're back, is hook up the case. So our menu's getting pretty filthy out here. There it is. It's getting pretty messy. We'll go through and clean that up in just a minute. It's not half as messy as that's getting, but that's all right. That's okay. Could use some elbows. We'll give this a rename. We'll call this noise type, because that's what it is. And we'll give this a rename as well, and we will call this normalize output. And let's just check to see if that works. So this is going out with whatever magnitudes the noise is being given. And if I turn that on, that should snap to 0 to 1 in a second. There we are. Yep, snap down to 0 to 1. Cool. I quite like that addition. Because some noises like this, you might want to leave like this and then do other stuff too. Whereas other noises you might want to just output to multiply something else with at a 0 to 1 range or something like that. So what we're going to go on to now is making us some detail before we hook up things like the new menu and change the interface and make things tidy. Let's add some detail. So what do I mean when I say detail? Well, let's get this back to, let's get it back to simplex for now. So let's just get some sort of basic shape out of the simplex noise that we might want to add some detail to. So this is suggesting itself to be a terrain, so let's have a look for a bit of a terrain. First thing I'm going to do is drop this frequency. Maybe not that much. Something like that could be quite nice. Try, oops, and get our element size up. Something like so. Yeah, that's pretty good. Amplitude's fine. Seed is probably fine. The colors are fine. So there we go. That's our simplex noise. Pop that off so we can work on it. So the point with noises is, and the way we've set this up quite deliberately from way back when I was explaining single dimension noise and stuff. I don't know if you even watched that, but this is turning into a longer series than I wanted it to be. But anyway, this here, what this is, what's actually coming out of this watch point is some data, and that data is, there we are, 58,081 points of data that in this case go from minus 0.8 to 0.8. What this is every single noise value for every single point on this. And the reason we've done it this way, and what's really nice about it, is that I can add or subtract to this and things will happen. And that's essentially how we're going to do detail. So we start with fractal noise. This is your normal everyday fractal noise. I'm going to use the same positions out here. So the same point positions that are feeding all of our noises will go into this fractal noise. And straight away, first thing I'm going to do is rename it. Badly. Detail noise. I mean, it could have been worse. I could have called it Daisy or, you know, Nathan or something. Or Nigel. But I'm going to call it detail noise instead. And this is your typical FBM noise that we went through just before. It's got all the same thing. It's exactly the same as that. But what we're going to do is we're going to take whatever comes out of here and add it to this. So we'll do that, and then we'll pass this entire thing back in. Now this will take a little while to work itself out, and some things have changed. Now, not much has changed because of the settings of this. And if we want to think about the way Houdini does it, the way Houdini does it is that it basically preloads this noise for you. You have some settings, and I believe Houdini are using the linearity and amplitude settings. We can do the same. We can build an FBM noise that'll do that, but I find that this gives us more control while still giving us something that, as an artist, I'm very familiar with. I'm just going to hook up the things that I can hook up, like the seed. Give it a minute to work itself out. There we go. So, Val, I hear you say, there's not much detail in there. Well, just wait. What about now? And what about if I do that? What happens then? Be aware too that the more frequencies you add, the longer things are going to take to happen. So now we're starting to get detail. You can see that the shape of our simplex that we set up is preserved, but the details being added to it by this magnitude here, it's keeping the rough shape of the simplex noise and then adding interesting details to it. This is a really old school and accepted way to do landscapes in computer graphics. It's layering noise. So here's our first layer and here's our second layer. And what's nice is about our second layer is it contains 6 other layers. Drop that back to 4. I'll get a little bit more speed out of it. You can see that you get quite a level of control here just by changing not even any of the settings. You're just changing the frequency ratio at this point. So we're going to like 0.4, where it's going to make it a bit rougher, but not as rough as it was. We can change the magnitude down to 0.8, and it's just going to drop the magnitude of that entire noise. But this is essentially how you make detail. So there are 3 types of detail in the mountain node in Houdini. One is this one. This is just called, I think it's just called default. It's an FBM noise that's added to the noise coming out of the node, which is great. And that means we've already got one. What we need to do is work out the other 2. The second one is called terrain, and what the terrain does is it flattens the low areas and leaves the high ones alone. And then there is a hybrid between, the third one is hybrid, which kind of accentuates what the terrain's doing. So if we use this as our base noise, the way we're going to do this is we're going to evaluate an fCurve on it, because it is just a sequence of floats. It's an array of floats like this, and we'll need to plug that into the right thing where it's actually going to do stuff like so. We'll leave it linear for now, and linear will be, nothing will change. Linear will be our default. Oh, something does change. Why does something change? That's a really, really good point. So what's happened here is, if we have a look at this data here, we'll see that what's coming out of this detail noise is not from 0 to 1. It's from roughly -1 to 1. But the way this curve works, and a friend of the channel, Frosty McFresh, who I will link to, has done a stunning video on fCurves and how they work, and I will send you all over there to watch that, because he explains it a lot better than I ever could. But essentially, this controls what the input is, and the input here is 0 to 1. I could change this by just changing this to -1 and -1. And now we've pretty much got the same as what we had. But the preset curves we are given are pretty much all from 0 to 1. So what I'm going to do is just a little bit of trickery. Well, not even trickery, just a little bit of bypassing. So I'm going to take this out. I'm going to do a change range on it. And to make that change range work so that I don't have to go through and look at this and go, well, it's -1.02554, and then type that in there, I'm going to go into here and drop down an array bounds node, like this. Lovely, lovely. And then the minimum can go into the from start. The maximum can go into the from end. Go back in here, turn off clamp, just because we want all of our information to be nice and free. And we're going to convert that to 0 to 1. So what this is basically doing is saying from this value to this value becomes from 0 to 1 with no clamp. Great. Let's just make ourselves a little bit more room over here. And so now we can plug that into the evaluate fCurve. Now it's all going to flatten because it's all going to go to 0 to 1. But to combat that one, we're then going to change. We're going to take this change range. Sorry, not the change range. We're going to add another change range. Like this. That goes in there. And we're just basically going to undo what we've just done. So it goes from 0 to 1 to that and that. And once more we'll turn off clamp. And we'll pop this back out. Give it a second. There we are. And so now what this system lets us do, and yeah, I know I'm cheating and stuff, but if I could find a way to actually input my points into the fCurve, that would be great. But since I can't, I'm going to do it this way. But what this lets me to do is I can now like drop down a preset curve and it'll change according to, which means we can start looking at, okay, so this is our lowest point. It doesn't have to be 0. This is now a representation, more or less. This is our lowest point. This is our highest point. How do we want our noise to get from our lowest point to our highest point? So if I want to flatten out the low points, but leave the high points as they are, I might want to do something like this. And then something like this. And you can see how these points, and I've exaggerated my details here to show this, but you can see that the lower the point gets down, the flatter and flatter and flatter it gets. Now this won't be reflected in the color because the color is, oh actually it might, because it's taking the actual values of the array and setting the range. Essentially I'm lowering the contrast in the low areas, but leaving the high points alone with this curve. Just pop that out so we can look at it. And I can just give it just a bit more adjustment so that it rises faster to the high points, or even if I want to just lift that up a little bit like so, I can do that. What I'm looking for is something that looks kind of like flat valleys and high mountains. Now if I pull this along so that my input, anything below 0.2 is now 0. And that's really starting to look more like terrain. Certain type of terrain, but terrain it is. So maybe if I just push back a little bit here. And you can change them here as well. So I'm quite liking that for my terrain setting. And the nice thing here is that I can just go to this, create value node. It's going to take those settings, make an fCurve for me. So we can check that fCurve out. There's the fCurve I set up. That's great. And then I can just break that connection. So I've now got an fCurve. If I change my name display to show and terrain, great. That could be my terrain. And then if I want to work on it again, I'll copy that down. I'll plug it into here. And I'll rename it to hybrid. So the hybrid's just a little bit less of a contrast, more or less. It's between our default, which is going to be just a linear straight curve, and whatever we set up our terrain curve to be. Now the nice thing is I can pump this whole thing out as a custom as well, and people can change that curve on the fly if they want to change their noise, which is something that Houdini doesn't really let you do. But for you Houdini users out there, this is just like using adding a curve to your interface and multiplying by the curve. Well, what do you guys call it? It's a graph or something? I can't remember. And I can't be bothered opening Houdini either to have a look, to be quite honest, because this is about Bifrost, not Houdini. Love you all, but hey. So easiest way here is to, I'll pop that out again because I'm forever doing this. I can now just start working with these a little bit to lift those, maybe make these like not quite so flat, like so, bringing this back to 0, like this. Maybe I do want it a little bit more flat than this. So I'll just take this to say 0.5 or so. What I'm looking for is a good balance between just a straight, everyday linear curve that is outputting what's put into it and what we've set up on our terrain. So this isn't looking too bad. I mean, you get a distorted view of it when you're up here in the mountains, but you can take a good look here. You know, there's nothing stopping me from adding my own Beziers in here. So it does something like that. Just going to really flatten it out. Just, you know, rather than doing this. So this would be a nice way to do, I don't know, sand dunes and ridges of rocks obviously our resolution is quite low, so you know, you're not going to be looking at dune level stuff here, but this is at least giving us an idea, and what's nice is our colors are reflecting it as well. But that, I don't want to do that, to be honest, so delete that point for now. I think, if we frame this, I think that this is pretty good for our hybrid. So we can always check by just hot swapping that, seeing the difference. There's our terrain, quite flat. There's our hybrid, not quite so flat. And then we just need to do one more, which is super simple. Grab that, go in here, reset to a linear, and this is our default. And I probably didn't need to put the little apostrophe after default, did I? So we've now got default, we've got hybrid, and we've got terrain. This is begging for me to put it into a menu. So I'm going to go away and I'm going to make another eval. Not eval, that's what that is. I'm going to make another enum and then I'll come back. All right, cheers. And we're back. So now we just have this little node called shape cases, which allows us to change cases. Terrain to default to custom, which isn't going to do anything right now because custom is this graph here, and it's something we're going to expose out to our users. So just to give you some proof that it's working, we'll pop that up there and see what happens. That's what happens. There you go. I'll put that back to its default. So just leave that empty for anybody to use as they want. And so this can go out to the interface as, and with that we are done with adding detail and controlling detail. Things are getting bigger and things are getting a little slow, so we need to spend a bit of an episode on optimization, which I'll do next. We also still need to get this sparse convolution noise sorted out that I've been promising you forever. I really should get on to like hacking my brain, beating my brain against a tree to understand it or something. It'll come, I'm sure. But now we have what is essentially a very big noise works. So the next thing we're going to do, and I'm going to do it in a separate episode, so it'll be coming real soon. The next thing we have to think about is, right now this is kind of controlled from outside of Bifrost entirely. If I close down Bifrost and bring back up, say, channel layer, select it, we've popped all of these out into the main level of Maya. And obviously we haven't put everything out, but we've put the noise control stuff out. So we have to work out whether we want to continue with that. Is that the way we want to control this? Do we want to have all of the attributes here, or do we want to set up an interface on our noise works and people will have to come into the Bifrost graph to change things, or some sort of combination of the two? I'll have a think about it and I'll probably show you one way or the other, but not both, as these things go. But for now, we're leaving it messy, but we're leaving it working. It's not the fastest in the world just yet. There are some things that we'll do together to speed that up somehow. But it is all there and it is all working. So, you know, I can change what type of noise I want. I want to make this into a Worley noise, which, because it's set to Chebyshev right now, it's going to make for some interesting detailed. You know, that's not too bad. It's not terrible. It's very blocky. So yeah, but what we do have is everything's working. So it's Worley and Euclidean to give us a bit more peak and fall away. All right, so I will leave you there, let you get on with your weekend, and I will do the same. So thank you very much, and I hope this has helped. See you next time.